Hello everyone, welcome back to SH Coding. In this video, we are going to discuss about the compilation process. By the end of the video, believe me, you are going to have a clear overview on the process of compilation. What is the internal process that is being occurred during the process of compilation? In the previous video, I have just tell the basic definition of the compilation, that is the process of converting into the machine code from the source code. In this video, we are going to discuss in detail about what are the process that is being carried out in the compiler. Okay, let's see the compilation process in C. Initially, it has the 6 boxes. These, it is a sort of flowchart that explains the entire process that is being occurred internally inside the system. From here is the source code that we give to the, that is we enter in the system. We will get the final output in this process, in this between, from the input we give and the output we get. Between these two, this much process is being carried out. We will discuss each and every point in detail. What is its purpose and how it is working. Okay. Initially, this first box represents the source code. It is the code which is being written by us in default. We will say the programmers. Okay, as we are the programmers, future programmers. Okay, it is the source code which is being stored in the file .c extension file. It is here the program.c we have written. Here the program is a place where we can write any name. It is a sort of file name with .c extension. Okay, now this source code is being stored in this .c extension file. After storing this .c source code in this .c extension file, it is moved to the next step, that is preprocessor. In the previous video, we have discussed that before the compilation process, initially the starting line, the preprocessor command hash include studio.h is being performed initially. It is one of its working step, but it has another 2 working steps as well. Initially, it will handle the first line hash include studio.h. It handles, and it also handles hash define. What is this hash define in detail? I will explain in the further videos. But as of now, remember, get an idea that in preprocessor step, it handles hash include. It also handles the hash define. In addition to this, it also handles to remove the comments. Okay. Now, what is this comments? Let's discuss. Okay. Now, what is the comments? What is the purpose of removing these comments? We will discuss. Yesterday we have seen this code. Now I will run it. Okay, I have run the code. It has appeared like my first C program. Now, what is this comments? Usually, these comments are helpful for us to recognize what actually this program is meant for. There is no necessity to write it. It is used to identify the program, what is meant for, I have said. So suppose in the future, we are going to write a program that is about 1,000 lines. For suppose the program code will be very larger, we have to write it. From the basic steps, we are starting as it is 9 lines between the spaces. So it's not big deal. But when it is a larger program, we will combine so many logics together. In that stage, we will get a confusion that why actually this logic we have used here. First, at some instance, we might face this problem as we are writing a very lengthy code, no? In that case, we actually use this comments. This here I am writing program to display my first C program. Okay, I have added this comment. The use of this comment is to represent what is meant. You can write any detail. There is no necessity that it has to say only that what is there inside the program. Nothing. It is a statement. It is a set of statements that we can write anything for our understanding. There will be no influence on the output. It is only used for understanding of bias. These hash is there, no? The two slashes are being used, no? These it represents as it is a comment line. If you remove these two slashes, then there will be an error in the output. You can see. You can see there is no change in the output. The same output is being appeared even though you have kept the comments. You can give these comments at any place. This is main, wait, this is main block. I have commented it like this. Now I have run. See, there is no change. You can keep these comments at any place. There will be no change. Why there is no change? That is being explained by this. In this processor, it handles both hash include and hash def. In addition to this, it helps in removing these comments. Before coming into the compilation only, these comments are being removed by this preprocessor. Because of this, these comments are being not influencing the code. Okay. This preprocessor gets the information that hashes, sorry, not hash, no, two classes are being used. No, it indicates that it is a comment. So it handles these three purposes. After the code is being modified now, the source code is somewhat modified. Now this modified code is being stored in a preprocessor file with .i extension. In the previous one, the source code is stored in .c extension. Now it is .i extension. Next, going to the third one, compilation. The purpose of this compilation is, first one is lexical analysis. What is this lexical analysis? The compiler converts this preprocessed code into the assemble code first, initially. Then the first stage is to lexical analysis. It breaks the code into the tokens. Tokens means the keywords, variables, operators. What are tokens? I will explain the next video only about the tokens. In that I will explain. But as of now, its first purpose is to divide the code into tokens. The next step is to analyze the syntax. What is this syntax? In the previous video, I have explained. In short, the syntax is a set of rules that tells us how to write a program correctly in that particular programming language. Okay. The syntax is used to the syntax analysis is used to see all the syntax are in a correct manner or not. If not, then the compilation is been stopped and we will get a pop-up of there is a error in the syntax. Okay. In the third, another work of this compiler is to semantic analysis. Here it will see the syntax error, whether the syntax is correct or not. Here coming to this semantic analysis, it tells us that all the logic that is being used is correct or not. Here actually logic, here I am explaining is differ from the logic that is we use in the common sense, common context. Actually, if we want to add two numbers, if for suppose 2 and 3 is to be added, 2 plus 3. In variables, if we want to write c is equals to a plus 3, it is a sort of logic. But here the logic is different. Here the logic is if you have initially declared some variable, declaring that I am using the variable name n, then you have to use the 10 in the next following sentences. If you have used instead of an m or t, then it will pop up as some error is being there in this logic. Okay, some undeclared variable is being appeared like that. In this context, for as of now, think that the work of this compiler is initially to break this code into logical blocks, okay, initially into the tokens, okay. Next, from tokens, it will analyze the syntax, any syntax error is there, all the syntaxes are correct or not. Next, coming to the third work is it checks all the logically it is correct or not. Means all the variables are correctly used. Everything it will check it out. If anything wrong, it will pop it out as something is wrong. Once recheck the code based on the error you made, it will appear like that. Again, the source code is being modified. Now this modified source code is being stored in the assemble file. The file name is dot with a dot s extension. Here the program, I mean file name is program. You can keep any file name as your name. I can write as sh.s. Here sh is a file name. It can be anything, but dot s extension should be dot x only. Sorry, dot s extension should be dot s only. Okay, it is the assemble file. Now this assemble file is sent into this assembler. This assembler is used to convert this assemble code, the code that is being present in this assemble file, into the machine code. Here the machine code, actually the source code is now converted into the machine code. Okay. Now converted into the machine code, then it is generated in object-to code. Of course, it is converted into a machine code, but it is still incomplete. Now it is converted into an object code. This object code is stored in the object file with .o extension. Initially, the source code is stored in a file with .c extension. Next, after some modifications by the processor, it is stored in a file with .a extension. Next, further modification in the compiler, it is stored in .s extension file, and further as modified by in the assembler. Now it is stored. Now this object code is stored in the object file with .o extension. Now this one is further moved to the linker. This block contains 3 works. It will perform 3 works. Link object files with the library function. We have initially discussed in the before video that a library studio.h is used. It is present. It is used to get the information to the compiler that what does that particular keyword is meant to perform. Okay. This linker is actually the key, plays a key role in connecting this library to this program. Now this linker, okay, with a simple example, I will try to explain it. For example, in this code you can see, the printf is being used. Okay. Now what this linker will do is, this linker, after seeing this printf, it will go to the library. It will search for what is the actual functionality of this printf. After getting the information, it will put into the code. Okay, it is used to connect this library and the program code. Okay, its first purpose is that. The second purpose is to resolve the external references. Usually the main block is there now. It is a reference. It has to be write as int main only. But we can write further functions. I have said that main is a function name. We can create as many functions we can. If you needed 4 functions in a program, we can create. What is this function? How to create this? I will explain the further videos, but as of now, get a small idea that we need a function. We need 2 functions or 3 functions in a program. We have mentioned in that mentioned the code related to the functions in the source code. Now all the functions should be linked to the main block. Okay, to the main functions, all the functions should be linked up. All these functions are linked to the main block by using this linker. It is the second work of this linker. Next, the third one is generate the executable file. After all the linkages have been done by this linker, the end work of this linker is to create an executable file. In Windows, it is stored in a file with .exe extension, but in Linux, it is stored as .out extension. Okay. Now the modified code is being stored in executable file. Now this executable file is further moved to this loader. When you double click on this executable file, I'll run it through the terminal. The operating system load it into the RAM. You all know what is RAM. It is a temporary storage unit where the data is being stored for some instance. Okay, now this, when we double click on this executable file, it is entered into the memory. It is the first point. It is the first work of this loader. The second one, I mean, in the first one only, the program instructions and the data have been placed in the memory. Okay, as I said, it has been stored in the memory so that we can access it when we need it. Okay, now the executable file is stored in the RAM, in the CPU. It is ready to work when we access it. Okay, now the second work is to transfer this control to the program. The CPU executes these instructions stored in the executable file and the program starts the running. I think something has been feel difficult when we reach this loader. I will explain clearly. After the executable file has been created, after the modified code has been stored in it, this executable file is stored, the code is stored in this executable file. Now when we double click on this executable file or run it on a terminal, the operating systems load this all the source code into the RAM, all the instructions and the source code into the RAM. The program's instructions and the data are placed in the memory now. So the CPU get the access to, the CPU get an access on it. Okay, now the CPU got an access from this first work. The second work is the CPU get the access, so it executes the instructions stored in the executable file and the program starts running. Now all the instructions are being run by the CPU. Now as a final result, the program is run. Now we will get a display on the screen. In simple sentence, for the entire process, we can say that the source code is written by us, by a programmer, passed through several stages. The first one is first one is preprocessor. First stage, second stage is compiler. Third stage is assembler, and the fourth stage is linker. From this, an executable file is created, which is then loaded into the memory and executed by the computer. And the display has been appeared on the system. Okay. For executing a code and displaying it on the system, if internally this much processing is being carried out, but we will get an output within very fraction of seconds. Yeah, very fast systems are being used in the present scenario. Okay, this is all the process that is being happening. This process known as compilation process. You can see the flow of the compilation over here. Okay, initially .c extension where the source code is being present. Next, preprocessor file with .a extension. With some modifications in the compiler, the assemble file is being created with .s extension. Further modifications by the assembler, .o extension file is being created with the modified code. It is known as object file. Next, move to the linkers. After linking all the links that has to be linked, the .exe extension file is created in Windows, whereas in Linux, .out extension file is created. Next, the program is run and executed on the monitor. Displayed on the monitor. This is all about the process of compilation. Okay guys, this is all about today's video. If you think the video is informative, please do like, share with your friends, and subscribe the channel. And comment if you have any sort of doubts related to this topic. And I have created a playlist. Please do save the playlist so that you can get all the videos at a single place. Okay, we will catch up later with the next video. Thank you.